Hey, good morning, everyone. So today we're going to take a look at what's known as elimination. So we have graphing, we've got the equal values method, we've got substitution. Each of those things allows us to find a point of intersection. So the last tool we're going to talk about in this class is what's known, like I said, as elimination. So think of this as kind of your last alternative. If nothing's set up for the equal values method or substitution, but terms are lined up. So in this case, if you see x's are lined up, y's are lined up, equals are lined up, and then the non-variable terms are lined up. Basically, we can add equations together to eliminate a variable. So the may require multiplication piece we'll get to later. That won't apply to example 1. So right here, if you notice, neither of these is set up with a y equals or x equals, and so that rules out equal values substitution right out of the gate. So what I'm going to do is I'm going to put a bar underneath. I'm going to think about my two sides. I'm just going to add these things together. So if you notice, what's 4x plus negative 4x? Turns out that's 0x. And then 8y, positive 8y plus 2y, it's going to be 10y. We still have our equal sign, and then we have 20 plus negative 30. And that's actually going to be negative 10. Notice how I have a 0x. Well, as we know, that's eliminated. It doesn't exist anymore. So really, I'm now left with positive 10y equals negative 10. And if you notice, I'm one step away from finding out what y is. So divide both sides by 10, and I get that y equals negative 1. Cool. So that might have looked pretty simple to you. You're like, oh man, why didn't we learn this before? Well, here's the catch. The next step is a little bit more difficult. So if I go back, I need to use an original equation to find x, but notice how these are kind of messy. So it doesn't matter which of the two I take. I'm just going to use the top one because it's all positives. So if I take 4x plus 8y equals 20, well, I now know that y is negative 1. So just like normal, I'm going to replace y with negative 1. And so now 8 times negative 1, I have 4x minus 8 equals 20. I'll add 8 to both sides. So now I have 4x is left equals 28. And then finally divide by 4, and I get that x equals 7. All right, so there's my point of intersection, 7, negative 1. All right, so once again, this part was really fast because when I added, my x eliminated right away. This part took longer because the equation's not set up to be a quick solve, so I have to put in for y, and then I kept solving until I got to our final answer. All right. So that's about as simple as elimination gets. For example 2, what I want us to think about, and I'm going to put a sticky note over the top just so we can kind of verify this. Let's say I tried to do what I just did. Let's say I try to add these things together. Well, this time, if I add these, I get negative 12x plus 12y equals 0. Notice how neither of my variables eliminated, because back here, remember, that right away got me a 0x and left me with just y. But in this case, I didn't eliminate a variable. And so basically, my strategy is not working. So I gotta adapt. So let's say I want to eliminate x. I have a negative 3x and a negative 9x. Well, when I'm thinking about this, what number plus negative 9x would be 0? Well, it would have to be a positive 9x. So what I'm going to do is I'm going to ignore this equation down here for a minute. I want this to be a positive 9x so that when I add it with the other equation, I get 0x. Well, what would I have to multiply negative 3 by to get positive 9? Turns out I would have to do negative 3 times negative 3 to get that. Remember, our property of equations is as long as I do something to one side and do it to the other, my equation is still equal. So that means I'm going to multiply the left side by negative 3, both terms, and the right side by negative 3. All right, when I do this, now this becomes a positive 9x minus 21y equals positive 48. This equation, I'm not doing anything to. I'm going to keep it as it is. All right, so once again, I wanted this to be a positive 9. To make that happen, I had to multiply by negative 3, and I did that to both sides. So that equation turned into this. The bottom one, I kept the same. Now, if you notice, let's add them together this time. So 9x plus negative 9x, once again, I get 0x. Negative 21y plus 5y is going to be negative 16y. And 48 plus 16 is going to be 64. All right, so now that 0x is eliminated, leaving me with negative 16y equals 64. And if I divide both sides by negative 16, I'm going to get that y equals negative 4. All right, so once again, I can use either equation. It doesn't matter. I can use the original top one or the original bottom one. I'm going to use the original bottom one just to mix it up this time. All right, now that I know y is negative 4, I'm just replacing y with negative 4. I'm going to multiply those, giving me negative 9x minus 20 equals 16. I'll add 20 to both sides to get negative 9x equals 36. And then finally, I'll divide both sides by negative 9 to get that x also equals negative 4 in this case. So my point of intersection is negative 4, negative 4. All right, so once again, once I did my quick multiplication step, all I had to do was add, eliminate a variable, which allowed me to find y, and then I put that into one of the original equations, in this case the second one, and that's how I got x. All right, so now we've got one more example, and this is probably the hardest one. It follows all the same principles, but if you notice, 5 and 3, there's no way to make 3 go into 5 or 5 go into 3. There's no way to make 4 go into 6 or 6 to go into 4, and so this one's a little bit harder. And if you notice, there's no way I can add or add to make either variable get eliminated. So now I need to think, what number could I use to make sure there's elimination? This time, rather than eliminating x, I'm going to choose to eliminate y. I could eliminate x in this case if I wanted to, but I'm going to choose y this time. I see 4 and 6. What is the least common multiple of 4 and 6? So I'm going to write that to the side. The LCM of 4 and 6, 4 and 6 actually both go into 12. I could use 24 if I wanted. There's nothing wrong with using 24, but 12 is the least common multiple. It's going to be the easiest to use, so I'm going to do that. So now I'm thinking, if both of these were 12, then I might be able to eliminate, but one of them would have to be negative so that when I add them, they cancel each other out. So let's say I try to make this positive 4y a negative 12y. To do that, I would have to multiply both sides by negative 3. So that's now going to become a negative 15x minus 12y equals positive 42. In this case, I need that 6y to become a positive 12y so that it'll eliminate when I add. Well, 6 times what is 12? That's 2. So I'm going to have to multiply both sides of the bottom equation by 2. So 2 times 3x, 2 times 6y, and then 2 times 6. So that's going to turn into 6x plus 12y equals 12. Now, if you notice, I have a negative 12y and a positive 12y. So I'm betting when I use my elimination strategy by adding them together, this is going to become negative 15x plus 6x will be negative 9x. These will become plus 0y. And then these will become positive 54. All right, and now I have a 0y that's effectively been eliminated. So now I have negative 9x equals 54. I'll divide by negative 9, divide by negative 9, and I'll get x equals negative 6. All right, so one more time. This was just like example 2, but in this case, negative 3 could conveniently go into 9, and so all I had to do was change the top equation. But this one, 5 couldn't go into 3, and 3 couldn't go into 5, 4 couldn't go into 6, and 6 couldn't go into 4, so there wasn't a convenient thing to multiply one equation by. So I had to think about the least common multiples of 2 of the numbers attached to variables, and in this case I found 12, and so I had to adjust both equations. If you had chosen to eliminate x, you could have used 15 because there's a 5x and a 3x, and that would have meant multiplying by something different down here. Feel free to try that on your own. You'll end up with the same exact answers. All right. So now I'm going to take the bottom equation in this one just because I feel like it. I could have taken the top. Doesn't matter. But I'm asking for a point of intersection, so I still got to go find y now. So I found out that x is negative 6. A lot of 6's in this one. All right, 3 times negative 6 will be negative 18, plus 6y will be 6. Add 18 to both sides. I'll get 6y equals 24. And then I can divide by 6, and I get y must equal 4. So my point of intersection is negative 6, positive 4. And that's it. So this is our final strategy. And all I need to do is say, if the x's are lined up, the y's are lined up, equals, and the non-variable terms are lined up, elimination is the way to go. In some cases, I can just eliminate immediately. Sometimes I have to adjust one equation, or sometimes I have to adjust both equations through multiplication before elimination works. As always, reach out if you have questions. Otherwise, good luck on today's assignment.